Okay, welcome to another video. Now this session is basically a recap session where I'm going to try to recap the entire syllabus for each component separately in separate videos. This particular video is about the S2 syllabus. So if you are in your second year of A levels and doing A level math and doing S2 specifically, this video is for you. What I'm going to try to do is I'm going to go through this PDF that I have in front of me. These are basically my class lectures that I've solved in detail, and you would have seen the videos if you've been following the channel. And what I'm going to try to do here is in the next hour or so, I'm going to try to recap everything that's there in the syllabus for you to sort of recall. This video would be more useful on the last day of the exam, but I thought I should record this and put it up even right now for those of you who want to recap the things. Unfortunately, I will not be able to create a separate PDF for the formulas, etc. So I would encourage you to stop and grab a pen and paper and a notebook or something where you can keep writing things down as I go through the topics. The first topic for S2 is generally the Poisson distribution. That is what we usually cover. Now for the first topic then, you base your calculations on a particular formula. You can probably see the formula written here. It says e power minus lambda into lambda power r over r factorial, and that's the formula that you need to remember. It's also there in the formula sheet. Poisson distribution is also important for hypothesis testing, as you may have seen before, and I would encourage you to do this properly so that you could essentially end up with two different questions on Poisson distribution, one with just probability calculations and one with hypothesis testing. So just put this down. Okay, starting with Poisson distribution. Poisson distributions are for particular variables. It says consider these variables: the number of emergency calls received by an ambulance control in an hour, the number of vehicles approaching a motorway toll bridge, the number of flaws in a meter of length. What you see is two characteristics of all these distributions, that there is an interval of time or space given to you. For example, this says a control in an hour, in a 5-minute interval, in a meter length of material. This is the interval that we are talking about. So conditions for a Poisson distribution are that events occur singly and at random in a given interval, time or space, and lambda, the mean number of occurrences in a given interval, is known and finite. Those are two conditions that you must remember. They come up in the questions as well, and that is what you need to know. So the Poisson distribution has just one parameter, and that is lambda. Lambda represents the mean number of occurrences in a given interval. Starting, you can see some basic questions where you don't have to change anything. It's just about calculating probabilities. What you need to know is that there are two specific outcomes that are useful. Although there is a formula, but when you have probability of 0, it's simply e power minus lambda, and when you have probability of 1, it's lambda e power minus lambda. These come in handy when lambda is unknown in a particular question, and you will come across several questions in the past papers where lambda is unknown. When you are calculating probability of a range of numbers, when it's less than, you can just add up the numbers and then put them there. But when it's greater than, remember that the Poisson distribution goes up to infinity, so you can't calculate that. So you use this idea that you learn in your AS level S1 exam, where you subtract the probabilities that you don't want from 1 to get the remaining probabilities. The sum of probabilities always remains as 1. You can stop at any question and review it if you want, and that should help you get through this topic. Then what happens in a Poisson distribution is that I could change the interval. For example, if I tell you that the number of flaws in a meter length of dress, it's not necessary that all my questions will be about 1 meter lengths. They could be about 3 meter lengths, they could also be about half a meter length. So I will have to change my lambda accordingly. Now, in order to change lambda, it's a simple idea. You use ratios or the unitary method, whatever you call it. That's something that you learn in O level. You can also avoid that entirely, do some mental calculations and get to your lambda, and that should help you calculate the probabilities of different intervals depending on the question. Then these are all questions about, if I do this, no, that won't be visible. Okay, let's keep it that way. So there are numerous questions then about all of this, where lambda is unknown or something like that. Some interesting questions about real life applications as well. If you haven't seen this question, you should go back and see this. It's there in the lecture videos as well. I'm stopping it on the screen so that you can pause it and do the question if you want an interesting question that helps you get to understand the idea of the Poisson distribution. That's the solution for this question if you are stopping it somewhere. Then one thing that I've noticed in this chapter is that a lot of questions have now started coming about. A lot of questions are now about conditional probability. So remember that conditional probability was just given that condition. Now conditional probability becomes a little more challenging. If I were to write this here, A intersection B. In these cases, so when you are doing these questions that have given that, think about what probabilities you've taken in the new denominator. Some of those probabilities will also appear in the numerator, so you should always calculate your denominator first and then your numerator. Whatever calculations you do in your denominator, some of those will appear in the numerator. No other calculations, no additional multiplication would be required, no other calculations would be required in the numerator. Remember that A intersection B does not always mean that you need to multiply those two together. A intersection B might simply just be the intersection of two events depending on the question that you have. Okay, then that's one thing that you need to be aware of. Then it's the sum of independent Poisson variables, so that's sort of related to linear combination of variables as well, and we're going to come across that as well. But the simple idea is that if you have two different variables with two different lambdas, the lambdas get added together. So you need to sort of add the lambdas whenever you have such a question. It says, for example, two radioactive substances emit on average 3.2 electrons and 1.3 electrons. Calculate the probability of a total of exactly 3 electrons. So when it says total, I'm asking you to add the two together. Questions can get a little confusing as well, so you should try out the questions that are there in the more recent past papers and sort of see if you get them right. If you don't get them right, try to find out the mistake yourself, or you can drop a message on my Instagram for me to solve those questions for you. Okay. Then you have mean and variance of a Poisson distribution. That says mean is also lambda and variance is also lambda. So that's something that's simple. Why is it used? That's mode of the Poisson distribution. Now that's something that I've never seen on the exam, but you should notice this, that in general, if lambda is an integer, there are two modes, lambda minus 1 and lambda, and in general, if lambda is not an integer, the mode is the integer below lambda. So that means that it can be bimodal or just one mode. Mode is simply the number with the highest probability. So these are basically derived outcomes, numbers that give you the highest probability, and therefore modes. Now the Poisson distribution can be used as a replacement of the binomial distribution. Now a lot of you get confused as to when this conversion is needed. Remember that this conversion is needed when you have, for example, let's say you have a question where you're given the probability of success and the number of trials. That's where you start thinking about a conversion from binomial to Poisson. The reason is that binomial questions usually don't appear on your S2 exam. So you should that should click when you see a binomial question, that unless it's a hypothesis testing question, otherwise it won't come up. A binomial question won't come up on its own. So let's say it says eggs are packed into boxes of 500, on average 0.7% of the eggs are to be broken. So that should tell you that this is a binomial distribution. But this is an unusual binomial distribution because P is really small and N is large. So whenever N was large in S1, you used to go to the normal distribution. But now since you have the option of going to the Poisson distribution as well, you go to the Poisson distribution. Why? Because N is large and P is small. Again, for normal distribution, you should remember that these were the conditions. If these conditions weren't met, you couldn't do a normal distribution. Now, if you were to calculate here, for example, if you were to calculate here, you'd find that NP and NQ are not both greater than 5. Therefore, I cannot actually apply a normal distribution. I have to stick to the Poisson distribution. Then these questions are about that. You can pause on any question you want and try to do them. Then the normal approximation to the Poisson distribution. Sometimes the Poisson distribution becomes inaccurate because lambda becomes large. So when lambda becomes large, the normal distribution can be used as an approximation where x follows a normal distribution with mean and variance both as lambda. That's something that you did right a couple of minutes ago, where I said that mean and variance are both lambda. So when you're converting, remember this. Again, when you're converting from a Poisson distribution to a normal distribution, one thing that you should remember is continuity corrections. It's also written here. You're using as an approximation to a discrete one, so a continuity correction is needed. That's something that you need to remember. If you don't know the rules for continuity correction, please look up the normal approximation video on my channel and you should be able to find the rules. All these questions are then about the Poisson approximation and so on. Then the next chapter that you have is linear combination of variables. Now for linear combination of variables, you need to be very careful with the wording of the question. That's where the trick lies. The questions are not difficult. Again, this chapter relies heavily on your understanding of the normal distribution. So if you don't know your normal distribution, please go back and revise those rules, because unless you know normal distribution, you will not be able to do this chapter. Okay. First, when you are transforming a certain variable, transforming variables such that you are scaling your marks, you're multiplying your marks by 2, or you're adding marks to everybody's marks in the class, then there are certain transformations that are happening. So your original marks, for example, were x, they're getting multiplied with a, and b is being added. So what happens is that the mean of the original marks also gets multiplied with a, and b is added to those marks. So the mean changes. How it's going to change is multiplication and an addition that is going to happen, whatever happened to the individual marks. The difference is in the variance. Adding something to a variable does not affect the variance, so you don't see any transformation happening here. But when you multiply everybody's marks by a, or multiply a number by a, or scale someone's marks, the variance gets multiplied with a square. These are two important outcomes that you should remember, and there are questions on scaling. For example, I've created some questions here. You can see them on the screen to see what I've done. And you can also have questions like this, where I ask you to construct an expression for a cost or something else, and then I ask you to sort of find the expectation and variance. So you can stop at this question, look at this carefully, and then move on. Again, I've done some past paper questions as well. Then the sum of independent normal variables. For example, you're giving both the S2 and the P3 exam right now. So your marks could be, your teacher would want to add your marks. So what's going to happen is that if you want to add up two variables, their means also get added and their variances also get added. So that's a very simple outcome. So you need to remember that. But if let's say your S2 marks were also getting scaled and your P3 marks were also getting scaled, then that would be the outcome for the mean, and those would be the outcomes for the variance. Then this question is interesting. You should go over this question. I explain it with a lot of detail in the lecture videos. If you haven't seen those, please go back and see them. It's another question. Then now I'm going to focus on the wording of the question, and I'm going to tell you how to spot the difference between more than one observation and multiples of random variable. Now, more than one observation means that, for example, let's see a particular question. It says masses of a particular article are normally distributed with 20 and standard deviation of 2. A random sample of 12 such articles is chosen. So you've chosen the same article from those group of articles 12 times. Not 12 times, 12 such articles were chosen. So multiple observations of the same variable were taken. Now, in this case, the mean gets multiplied by 12 and the variance gets also multiplied by 12. Remember that this outcome is different from the previous outcome, and I'm going to explain it to you in a little bit what the difference in this outcome is. But you can try and do this question if you want. There is another more interesting question about overloading a lift, so you can do that too. Moving on quickly to the difference of independent normal variables. So you could be adding variables together and you could be subtracting variables. Now the primary difference is that when you are adding variables, it's obvious that the mean gets added and the variance also gets added. But when you are subtracting variables, the mean gets subtracted, but the variance will again get added. So that's something that you need to remember when you are doing questions. Now, when do you subtract variables? Again, the question will sometimes say this. For example, in this question, there is a machine that's packing balls into a box or a tube, cylindrical tubes. It's saying if a ball selected at random is placed in a tube selected at random, what is the distribution of the clearance? Now, the clearance is the internal diameter of the tube minus the diameter of the ball. So, clearance is basically tube minus ball. So that's when you subtract the variables. So you're going to construct a normal distribution for the clearance and then try to solve the question, whatever the question is asking you. I can stop here and you can try to do the question if you want. Pause it. Moving on quickly, sometimes the subtraction isn't very obvious. Sometimes what's going to happen is it's going to ask you to, let's say I show you and go back and show you this question. It says weights of garden tables are normally distributed with mean this and variance that. Weights of garden chairs are normally distributed. Find the probability that the total of 2 randomly chosen tables is more than the total weight of 10 randomly chosen chairs. So first I've written 2t is greater than 10c, but I know that I can't calculate on both sides. I need a number on the other side. So I move this here and I create a new variable called 2t minus 10c, 2 tables minus 10 chairs. Now this is illustrating two different concepts that I've just taught you. One of the concepts is that there's a difference of variables. As you can see, it's 2t minus 10c, and the other is more than one observation. So I'm not just talking about one table, I'm talking about two tables. I'm just not talking about one chair, I'm talking about 10 chairs. So the mean and variance will get adjusted accordingly. Make sure that you understand this idea, because if you don't, the next part of this topic will be very challenging for you. Moving on. Then the trouble actually lies when you talk about multiples of independent normal variables. Now multiples is the same as scaling. There is going to be a difference in the wording of the question, and the best question that I can show you, the best idea that I can show you is here on the screen. It says great care must be taken in distinguishing between a sum of random variables and a multiple of a random variable. For example, if x is the weight of a small loaf, then the sum x1 plus x2 plus x3 is the total weight of 3 loaves. So the sum of different observations would lead to this mean and this variance, both get multiplied by 3. But if there is a large economy size loaf is 3 times the weight of a small loaf, then the weight of an economy loaf is 3x, which is a multiple. So when I'm talking about thrice the size, I multiply the mean by 3 but the variance by 3 square, which is 9. So that is the difference between more than one observation and multiple of observation. So I generally call it multiple observations and multiples. So you need to decide whenever you're doing a question whether it's a question on multiple observations or multiples only. So this question again illustrates this idea. One of these is about multiple observations, the other is about multiples only. So when I'm talking about 4 times, it's about multiples, but when I'm talking about 4 small bottles, it's multiple observations. So remember to diagnose the question before you try to do it, because when you rush through questions you often get them wrong. Then I do a lot of practice questions on this. Let's quickly move on to the next topic that we have. The third topic in this uh, series, in this syllabus, is continuous random variable. Now with continuous random variable, you've done discrete random variable in S1, where you construct a table of probabilities and you say that these are the possible values of X, and you calculate the probability of each of these. Well, those are for discrete variables, the number of pens, the number of balls, the number of games that you win. You come across lots of questions in S1. But not all variables are discrete, some variables are continuous. So for continuous variables, what we have is probability density functions. These are functions that help you calculate probability. What you basically end up doing is you calculate area under those functions to calculate probability. If you integrate over the entire domain, you get 1. If you integrate with limits, you get integrate with particular limits, you get the probability of a number within those ranges. Now with discrete random variable, you can pick out a number that you want to calculate the probability for, but with continuous random variables, it's a range that you have to see in order to get your probability. Okay, again, simple questions. Remember that in this chapter you will have to show your integration working. Now any integration could come up. You could have integration on integration by parts. I've never seen a question on substitution. Parts is more common here. And you could have very simple integration that you learn in P1 as well. So there's no stopping the examiner from creating different functions. You could have 1 over x being integrated. I've seen an ln x as well, and e power x as well, or e power function of x as well. So different questions could come up in different places. This chapter is largely about integration, so as long as you know your integration, you'll be fine doing this. But since your P3 exam is after your S2 exam, make sure that you better practice a bit of integration by parts, know your formulas before you go on and attempt the S2 exam. Then you have different questions where you have to find sometimes unknowns. When you have to find unknowns, you use the idea that the entire probability should integrate to 1. This is a question with an exponential. You can see that you will sometimes be asked to do some working with logarithms as well. You will also be asked to sketch the function. You can stop here and try to do this question if you want. This is a past paper question from June 2010. Then for the expectation, you have a formula. When you were doing discrete random variable, there was the formula called sum of x px. This time the formula is x f of x integrated over the entire domain, and that should give you the expectation. Remember that a lot of people get confused when the answer comes up more than 1, but expectations can be more than 1. They can also be negative depending on the question. So make sure that you read the question properly. Then you can also have more wordy questions like this one. I would encourage you to stop here and solve this if you haven't already, and then try to see if you understand what the solution says. Then expectation, then some modeling questions. You can go over the question if you want. Stop here and do that. Then variance of x. Again, variance of x has a formula in that you need to remember that dx is here, so you integrate up to here and then you subtract the mean square. So you will need the mean when you are integrating for the variance, and you integrate over the entire domain again. Okay. The mode is the number with the highest probability. So when you are doing this in continuous random variable, what you need to remember is that the mode is going to be the highest point of the curve. So the highest point of the curve can sometimes be pointed like that, or just the end point, or the starting point, or what I've seen in questions is there is usually a quadratic curve. So the middle point of that quadratic curve, basically the x coordinate of the turning point, is going to be your mode. So the questions might come up where you have to do a bit of differentiation as well. Again, that's going to be basic differentiation, hopefully, so you don't need to worry about very complicated differentiation. But again, that's something that you need to know. Again, also quadratics has different ways of calculating turning points. Make sure that you remember those. Sometimes those questions are just about interpretation, so you need to know those as well. This is a question with a turning point in a quadratic situation, so make sure that you understand it before you move on. Okay, then the last part of this topic is finding medians and quartiles. Remember that median is not simply half of the domain. Median is a point on the domain where you are sort of accumulating 50% of the probability. So 50% probability means the median. So the median could come up very late if it's a function like this, and it could come up early when it's a function like in fact, this comes up late as well because it's slow, but you could have different medians depending on the curve. Okay, so median is 50% probability. If you are integrating from the start of the domain up to the lower quartile, that's 25% probability. If you are integrating from the start of the domain to the upper quartile, that's 75% probability. So those are calculations that you need to know. Again, the domain would be unknown, or the limits would be unknown in this case, and you might have to do a bit of logarithms like I've done in this question. So do this question, that should help you understand the basic idea. For quartiles, I've already told you that's what you need to do. That's the diagram that shows you the probabilities up to every point. So if you're starting from your start of the domain, remember where the upper quartile and lower quartile are. If the question asks you interquartile range, remember that you can't just use one equation to solve for both the upper quartile and the lower quartile. You will have to create two separate equations in order to get the upper quartile and lower quartile. Then this is a more interesting question that you need to understand. I've done this in detail in one of my videos, and this is a question from November 11. Open up this question and try to do it. Understand what it says. If you aren't able to do it, go back and watch it in the video, or you can send me the question on Instagram, and I should be able to follow it up at some point. Okay, moving on to the next chapter, that is sampling, estimation, and probability. Now, the first part of sampling is certainly a time-consuming topic, so I'm not going to go over the entire topic. But what I'm going to do is I'm going to just breeze through this. If you haven't done your theory in a lot of detail, make sure that you do it because it comes up very often. You should be able to use the random number tables or the random number lists that are given to you in this chapter. Sampling has a lot of definitions. You need to know what a population is, you need to know what a sample is, you need to know what a census is. So that is coming up here. If you want to read this, you can pause and read this. I'll go through slower with this. Then why do you do a sample survey? That's also something that's often asked. Sample design is something that you need to know. I've never seen it on the exam though. But it helps you understand what sampling is. Then bias is something that comes up very often. Where does bias come from? It's written here. You can read through these lines and you should be able to get a better understanding of what bias is. Now, sampling methods are also important. Drawing lots is basically, in Urdu, हम कहते हैं पर्चियाँ डालना, that's drawing lots. So or using random number tables, so that's something that you need to know. So that's drawing lots, random number sampling. In the exam, you can be asked to do a sample from random numbers in a list of numbers that you might be given, and then asked to do sampling using random number tables. So remember how to do that. You should also be able to do systematic sampling. That's something that also comes up. So read through this, that's there on the screen. Pause it here and see if you understand it. Then it tells you advantages and disadvantages, and the stratified sampling. I've never seen all of this, but you should know this just for general understanding as well. That's one question that I've done. That's another question that I've done. Please stop and pause wherever you want so that you understand what's going on. Then unbiased estimates of population parameters, or they're also called point estimates. In order to remove the bias, what we say is that if you've taken a reasonably sized sample that's random, the bias in and the mean is automatically removed. But for the variance, you need to use this formula for unbiased estimates. Remember that they're still estimates, they're not um, exact population parameters. They are estimates of the population parameters. So if you take the sample variance and you multiply it with n over n minus 1, you get the population variance. Remember that on the formula sheet there's a different sort of formula there. So if you understand that formula, go ahead and do that. But if you don't, you remember that when you are calculating the sample variance, you will often be expected to do the S1 formula that you learned there, sum of x square over n minus mean square, or the one with f of x. Remember that formula. If you don't remember that, you should open up the formula sheet and see what's there. This is also called point estimates. That's what I've written here. That's one question that I have done on the exam, on the lecture. If you've not seen it, please see it now and try to solve it on your own. That should give you an understanding of what we're talking about. Then that's some random number tables and all of that. Then this confuses a lot of people. This chapter is then the distribution of the sample mean. Now when you're talking about the distribution of the sample mean, what I'm talking about a distribution for x bar. Now it's difficult to explain this without having an actual sort of data set, but briefly, if I were to tell you, let's say if I have total 10,000 students in the school, and let's say every class has 50 students, and what I do is I sort of want to essentially find out the distribution of all these students. But what I do is I can't send just one person to find out the marks of, let's say, all these 10,000 students. So I hire about let's say 200 people to go on and do the task. Okay, so what each person would then be doing is that each of those 200 people will be collecting data on 50 students. Now when they have data of 50 students, what they do is they summarize the data set. What they do is they calculate the x bar for each of those classes. So I have class 1, class 2 up till class 200, and what I have is a number of x bar values. Now those x bars can then form a distribution themselves, and when I look at the distribution of marks or m bar, the mu is the same as the mean of the marks, but the variance is divided by n. That's something that you need to understand, that if I were to take all 10,000 observations on their own, they would have this mean and variance. But if I take those 200 summarized data sets, they will have this distribution. It's normal, it's a normal distribution, and that's going to come up later on. That's what you need to know. These questions are very frequent on the exam. Now for example, if I show you this question from the past papers, that will help you understand when to do this. It says a clock contains 4 new batteries, each of which gives a voltage which is normally distributed with mean this and that. The voltage of batteries are independent. The clock will only work if the total voltage is greater than 5.95. Find the probability that the clock will work. So the clock will work when the total voltage. So this question is about linear combination of variables. But then I ask you find the probability that the average total voltage. So I'm asking you for voltage of the batteries of 20 clocks. So I'm asking you for the mean and variance of the average total voltage. So I've written C bar here. So C had a normal distribution that I found out here. That was the total voltage that every clock needs to have. Every clock has a mean of 6.16 and 0.01 as the variance. But average total voltage has a distribution. That's this. So when I want to find the probability of average, I say C bar, and then or whatever the question might be. I could also have said T bar and then sort of solve this question. So that's the difference in the wording of the question. A lot of people get confused in this question because of its resemblance to linear combination of variables. So remember, linear combination of variables is generally about totals or times and things like that. But whenever you see the word mean or average being used, this question is about sampling. So that is about sampling. These questions can come up. Then there's the central limit theorem. Central limit theorem basically says that All these distributions become normal. When do they become normal? When the sample size is large. If the distribution is unknown but you've taken a large enough sample, is basically n is greater than or equals to 30. That's what the book says here. So that's your benchmark. So if n is greater than or equals to 30, all distributions of x bar, or the sampling mean, would start resembling a normal distribution. But even if the sample is not large, let's say you just took let's say 20 observations in that, and let's say you didn't know what the original distribution was, and you said it's not normal, or it's a Poisson distribution or binomial distribution. What you then do is, in order to calculate the probability of the sampling mean, you assume. So the questions are sometimes about, do you need to assume? So you will decide based on what your sample size is. If your sample size is large, then you don't need to assume. Then the central limit theorem automatically comes into play. But central limit theorem only comes into play when n is large. If it's n is not large, then you need to assume that the distribution is normal. Then sometimes the question is, was the CLT needed in this question? Now, when is CLT needed? When the distribution of the original, for example, marks or batteries, is not normal. When the distribution is not normal and n is large, then CLT automatically comes into play. But if the original distribution was normal, then you won't need CLT, and therefore CLT is not applicable there. But if the distribution is not normal and the sample size is also small, CLT does not work. In that case, you end up assuming that the distribution is normal. So that's something that you need to be aware of. These questions come up as theory questions. I think there's something about it here. So you need to see this if you haven't seen this before. Then the second part of this topic is about, since I've separated this, is about confidence intervals. Now, confidence intervals is something that you've already seen. You need to remember the formulas, you need to remember the probabilities, remember that confidence intervals are symmetric. Therefore, if I tell you 90% of confidence interval, then you from the normal distribution table, you're going to read a probability for 95%. I would ideally expect you to remember these three because it comes in handy, but you can also end up with a 98% confidence interval or a 97% confidence interval. Even in those cases, you're going to create a symmetry and then read the table, whatever the table is, whatever the percentage or probability that you've been given. Then the formula for the confidence interval of the population mean. Now I'm talking about the population mean, so I use x bar on both sides and then a plus z value into sigma divided by root n. Remember that the sigma is the population variance, a population standard deviation. So if you're not given the population standard deviation, you're just given a sampling standard deviation, you will need to unbias it and then sort of go ahead and calculate. By unbiasing, I mean multiplying by n over n minus 1. So again, some questions, you can go over them. The real challenge in these questions comes up when you have the confidence interval as unknown. Otherwise, questions are simple. That's something that I want you to remember. That's the formula for width. So that's 2 into z value into sigma over root n. Again, some questions. Okay, with these questions, again, if you're given a confidence interval, remember that you can quickly calculate x bar from that. X bar is always the midpoint of the confidence interval. If you're given the confidence interval and you're asked to calculate x bar, that's how you calculate. You don't go and create a simultaneous equation. It's going to make it more complicated. So x bar is the midpoint of the population confidence interval. Detailed question, you could go over that. Then confidence intervals can also be there for Population proportions. Now, what's the difference between a population mean and a population proportion? For example, if I was talking about marks, the data for marks, I would create a confidence interval for a population proportion. But let's say I was talking about a quality. Let's say I own a factory that produces pens. So my interest is not in the mean number of pens. It's or the mean hours of that they're in class. I'm trying to figure out faulty pens, for example. So I can't say that there's a mean for faulty pens. What I'm going to say is there's a proportion for faulty pens. Let's say I pick out 100 pens, how many are faulty? Let's say 8 of them are faulty. So 8 over 100 is the sample proportion. Now, from the sample proportion, how do I construct a confidence interval for the population proportion? So this question is about that. I have written down the formula. I haven't written down the formula, but you can see these commas basically indicate a sort of boundary, but that's the lower boundary and that's the upper boundary. The formula more or less remains the same. The only thing that's been replaced is the variance. That's PS over QS over N. That's population proportion, success and failure divided by N. If you haven't done these questions, please go back and do them. They are important questions. Okay, I am pausing here for you to do this question if you want, and that should help you understand this topic. Okay, again, the midpoint of this interval would give you the population, the sample proportion. So if I've given you an interval like that, if you calculate the midpoint of this, it's going to give you sample proportion, which is called PS. Okay, that's why I call it. I call this PP, population proportion, and this is proportion from sample. Again, this question is solved, and you can look at this question. That is for this topic. Now, the last topic on this chapter is hypothesis testing. Now, hypothesis testing is something that I cannot possibly summarize because it's a detailed topic, and it's a process that you need to understand. For those of you who've already done the topic would understand that as long as you know the process, there is nothing difficult about this topic. As long as you understand the different ways the process works, when I sort of teach hypothesis testing, now there's an entire excerpt from a book that I've written here. If you want me to scroll through it slowly, you can pause and sort of understand whatever is written there. These are basically 3 different methods of doing a hypothesis test, and I sort of teach all 3 methods. Why? Because some questions require you to have that understanding. Sometimes there's some backward calculation involved, sometimes X bar is unknown, sometimes the significance level is unknown, and so on. So it's a process that you need to know. I cannot possibly tell you the entire process as a summary because that would not do justice to this topic. So the first part of this topic is about testing mu, or the mean of a population. So I go on and explain all of this in detail. Please go back and look at the video if you haven't already. And if you don't know hypothesis testing, there is a lot of detail to this topic that cannot be summarized. So, and even if I were to summarize that, you wouldn't probably be able to understand it right now. Lots of things to understand in terms of one tail, two tail, lower tail, upper tail test, how to determine the sign of the inequality, and so on. And those are all things that are necessary for you to understand hypothesis testing. Whenever I teach hypothesis testing, I tend to explain the testing of mu first, and then the testing of proportions and lambdas and so on. Then again, type 1 and type 2 errors. This table should help you with the theory questions at least, but type 1 and type 2 errors follow from your understanding of the hypothesis testing process, and that's something that you need to understand in depth before you do them. To be honest, these things cannot be summarized. Hypothesis test, again, I'm stopping here and you can read through this. Would give you a fair idea, but again, you need to understand this in detail. Type 1 and type 2 errors are also very important because they come up in a lot of theory questions as well. Those theory questions can about whether a type 1 error is occurring or a type 2 error is occurring, and so on. Okay. Again, all of this, I'm going to stop here for type 2. You can look at what I say about type 2. It's the acceptance using new mu. And again, you can have different questions with different unknowns. Questions do get a little complicated, but that's something that you will understand when you do a lot of practice. Then you have hypothesis testing using a binomial distribution. That's basically a hypothesis test for a binomial proportion. So you again are testing small p. Again, how will you know? There's the probability given in the question. Although you see, I sort of because I teach the normal distribution first, I tend to draw a small diagram that I then get rid of later on. But again, this is something that I cannot summarize. It's a detailed topic. It gets very confusing if you sort of rush through it, and it also asks you to calculate a lot of probabilities. So you see, I've done a lot of calculations there, which is why I keep telling you that the class-based calculator, I don't think I have it on my desk right now, but the class-based calculator is something that you should have for your S2 exam to calculate quickly. Okay, the summary of the rules is written on the right side. You can look at it if you want to recall something. Okay, then the same sort of things come up with type 1 and type 2 errors. Type 1 errors are tougher on the binomial testing. Make sure that you do the topic in proper detail. Even then you will feel a little shaky about type 1 and type 2 errors. Just make sure that you ask the problems, or you sort of go over the marking scheme, what the marking scheme says. In my lectures I try to come up with as many sort of there's not a lot of logic, but a lot of rote learning just to get you through the past papers. And that's something that matters when you're trying to get marks. The understanding comes with a lot of practice, and you will be able to do that too. Type 2 errors are even more challenging because binomial distribution, binomial testing is by default a challenging topic on the exam. Okay, quickly moving on. The last part of the topic is the same, but with Poisson distribution. Now when I'm talking about a Poisson distribution, I'm basically talking lambda. If you understand binomial testing, you will probably find Poisson testing to be the same. The only difference is that you will then have lambda and Poisson probabilities to calculate instead of binomial probabilities. Type 1 and type 2 errors again can be very challenging here, so make sure that you understand what each particular thing means, and then you sort of complete the topic. That brings us to the end of the syllabus, and although I've not done hypothesis testing in a lot of detail in this video, but what you need to understand is that hypothesis testing is by default a difficult topic. Once you understand the process, the topic becomes easier, but for you to understand the process, you need to replicate it multiple times with the help of past papers, and then sort of get a good grip over it. S2 is not very difficult to score in. Yes, you will come across parts that are more challenging, but if you stick to your basics and you and when going through the video you understood all the subparts that I was talking about, you are more or less prepared for the exam. Just make sure that if you're watching this on the last day, you go back and revise the questions that you had a problem in. Questions that you asked your teacher or you asked me, those are the questions that you should be rehearsing on the last day of the exam, and sort of figuring out what your mistakes were and not doing them again on the exam. If you are watching this video right now, I would encourage you to keep doing your past papers and try to see what your score is. The thresholds fluctuate a lot, and since this year the thresholds will be stricter than they've been in the past, you can expect grades to be lower than they've been in the past 3 years. So make sure that you're well prepared for the exam. If there are any questions, please drop a message to me on my Instagram, and hopefully I'll be able to answer those questions at an appropriate time. Please make sure to like and subscribe if you've watched this video and found it useful. Thank you.